Hello, I'm Lo.
And I'm Max.
Hello and welcome to the Climate Chronicles, a podcast dedicated to exploring how climate change is rehappening our world. I'm your host, Lo.
I'm Max.
And today we're diving into a topic that's particularly close to home for many of us. The effects of climate change on Miami, Florida.
Over the past few months, we've been studying climate change in depth. We've covered everything from paleoclimate data to the role of human activity in today's changing climate. Today we'll be applying what we've learned, focusing on how Miami, a city that sits at the intersection of vibrant culture, a booming tourism industry, and a delicate coastal ecosystem, will be impacted by a changing climate. Let's break it down.
To understand where we are going, it's helpful to look at where we've been. Earth's climate has fluctuated throughout its long history, with periods of extreme warmth and ice ages. These changes, known as paleoclimate, are studied using various methods, including ice cores, tree rings, and sediment samples. Scientists analyze the composition of these records to reconstruct the climate of its past.
For example, during the last ice age, which peaked about 20,000 years ago, much of Earth's water was locked in glaciers, lowering sea levels by as much as 120 meters. Over time, as the Earth warmed, those glaciers melted and sea levels rose. In fact, sea levels have fluctuated in cycles over the last several million years due to natural factors like shifts in Earth's orbit and volcanic activity. This past climate history helps scientists predict how much the Earth planet might warm in the future and how rising temperatures could affect our environments.
What drives change? Historically, Earth's climate has changed for several reasons. These include natural factors like volcanic eruptions, changes in solar radiation, and variations in Earth's orbit. For example, can release huge amounts of CO2 and ash into the atmosphere, which can either cause short-term cooling or warming depending on the specifics.
However, these natural forms of climate change occur over much longer timelines. What's concurring about today's climate change is that it's happening much faster than the past shifts, and it's largely driven by human activity, particularly the burning of fossil fuels, which causes more CO2 and carbon to go in the atmosphere, which makes climate change speed up and happen faster.
How heat moves through the system. Now let's talk about Earth's energy budget. Simply put, Earth receives energy from the sun, which warms the planet. This energy is absorbed by land, oceans, and the atmosphere. Earth then radiates some of this heat back into space, keeping the planet at a stable temperature at all times. But here's the catch. The balance between incoming and outgoing energy is shifting. Human activities, especially burning coal, oil, etc., are adding more greenhouse gases to the atmosphere, trapping heat. Think of Earth's atmosphere like a blanket. The more greenhouse gases we add, the thicker the blanket gets and the more heat that is trapped in the blanket.
Why we're warming up. The greenhouse effect is the process by which certain gases like carbon dioxide, methane, and nitrous oxide trap heat in the atmosphere. These gases let sunlight in but prevent some of the heat from leaving back into space. While this effect is natural and necessary for life as we know it, human activity has amplified it. In the past, atmospheric CO2 levels were stable, but since the Industrial Revolution, they've skyrocketed. Miami, with its coastal geography and warm climate, is especially vulnerable to this heat. A global temperature rise, cities like Miami face hotter summers, warmer winters, and more intense weather events like hurricanes.
Amplifying effects. As the Earth warms, certain processes act as feedback loops, either amplifying or reducing the effects of climate change. Positive feedback loops are self-reinforcing. For example, as ice and snow melt, they reveal darker ocean water or land beneath, which absorbs more heat, leading to further warming and more melting in places like Miami. The loss of coastal wetlands and mangroves can reduce the ability of the environment to buffer the effects of the storm and rising seas.
On the other hand, negative feedback loops help counteract warming. For example, increased evaporation might lead to more cloud cover, which can reflect more sunlight back into space, slightly cooling the Earth. But in the case of Miami, positive feedback loops are more of a concern. The city's low-lying geography makes it particularly vulnerable to rising sea level and storm surges.
What's driving today's change? For millennia, natural processes were the primary drivers of climate change, but in recent history, human activity has taken the lead. The burning of fossil fuels for energy, agriculture, and deforestation has dramatically increased the concentration of greenhouse gases in the atmosphere. While natural factors still play a role, scientists agree that human-caused climate change is the primary reason for the rapid shifts in temperature and weather patterns we're seeing today. And nowhere is this more evident than in cities like Miami, which have been experiencing rising sea levels, hotter temperatures, and more frequent and severe weather events.
What's happening now? Since the Industrial Revolution, the Earth has warmed by about 1.2 degrees Celsius, and Miami has felt that change acutely. Over the past few decades, Miami has seen an increase in average temperature, as well as more extreme weather events. This includes hurricanes that are more powerful and destructive than ever, as well as heavier rainfall leading to more flooding. The impacts are also visible in Miami's neighborhoods, particularly those that are situated near the coast. King tide flooding, which occurs during high tides and is now exuberated by rising sea levels, is becoming a regular occurrence in some parts of the city. Infrastructure like roads and buildings that were once safe from flooding are now at risk of being destroyed and taken out. How will Miami be affected exactly? Let's break it down.
How will it?
Temperature patterns. Miami will experience hotter summers, warmer winters, leading to discomfort for residents and added stress on the energy grid as people crank up their air conditioners.
Miami is already vulnerable to hurricanes, but climate change will likely make these storms more intense. Warmer ocean temperatures provide more fuel for these storms, leading to stronger winds, having heavier rains and more flooding.
Sea level rise. Miami is one of the most at-risk cities in the world for sea level rise. As the polar ice caps melt, sea levels are projected to rise by at least a foot by 2050. This could submerge large parts of Miami coastline, displacing residents and damaging people's property.
Ecosystems. The warming of the oceans and increasing acidification are already threatening marine life off Miami's coast. Coral reefs, which are critical for biodiversity and tourism, are dying due to heat stress and ocean acidification.
Local communities. Climate change could lead to mass migration, with residents forced to leave flood-prone areas. Communities that rely on tourism, fishing, and agriculture will see disruptions, affecting livelihoods and the local economy of Miami.
Our conclusion: climate change is already impacting Miami. If we don't act now, the future looks even more uncertain. But there is hope. By transitioning to renewable energy sources, reducing carbon emissions, and building more resilient infrastructure, we can reduce the worst effects of climate change.
The time to act is now, and cities like Miami have the opportunity to lead the way in creating a sustainable future for generations to come. Thank you for tuning in to Climate Chronicles. I hope today's discussion gave you a clear picture of how climate change will affect Miami in the future, and why it's so important that we all take responsibility for our planet's future and do what we can to slow down the effects of climate change.
Save Miami.